Okay, in our last video we looked at finding a resultant force based on component vectors, or based on vectors that were straight up and down and straight left and right. Obviously though, forces don't always act upon objects just in up, down, left, right motion. So what we're going to have to look at today is something like this purple diagram here, where we have a force being put on at various angles. So let's take a look at one example of those. We have an object that is being put on by two different forces, one at 216 degrees at 150 degrees, and one that's at 103 newtons at 315 degrees. So I've drawn this little force diagram right here, and if we want to look at where the resultant would be to begin with, again, if we go tail tip method, I can see that, well, based off that, it looks like my result should be somewhere in quadrant 2. If it helps, I'll draw another example of it. So we had the one angle going, well, let's draw this one in green up here, going that direction, and then it changed down to about right there. So your resultant would be the part that I have drawn now in green. That would be your resultant force somewhere in quadrant 2. The issue with this, though, is that we don't have straight up and down motion like we had in the last one. However, we said in the last video, though, too, that we could take any vector and break it down into x's and y's. So this guy has an x and y component. This one has a x and a y component. If we break both of those down with their individual angles that are in here, we can find exactly what our problem is going to entail, and how we're going to be able to find exactly the resultant and how much force and in what specific direction we are looking. Okay, so the way we're going to set this up is that we're going to have two things we've got to look at: the x component and the y component for each function, or for each force, I should say. And what we're going to do is we're going to find each of those for both forces, and then when we add them together, combine them together, we get our resultant in the end. Well, the easiest way to think about this is back to the unit circle. Your x component, x is cosine on the unit circle, y is sine on the unit circle. So the way we're going to do this to find each value is we're just going to say, well, based off of our unit circle and based off of our force, well, for force 1, well, the x component is cosine. Cosine of what angle? 150 degrees. Cosine is equal to this value over the hypotenuse. And what I mean by this value is that you have x over hypotenuse. It's almost like you're making this triangle right here. Okay? Y component would be the sine value. Sine of 150 equals y over your hypotenuse. And again, your hypotenuse being the actual force itself, the actual vector itself. Okay? X is up high, you multiply. In this one, y is up high, you multiply. So x equals 216 times cosine of 150. So that gives you an x component of 187.06 newtons. When y is up high, multiply 216 by sine of 150, and you get y equals exactly 108 newtons. So there's your x and y component for each of these. Now, here's the issue too. If you make sure you've done this in your calculator correctly, cosine of 150, when you plug into your calculator, hopefully, if you're in the right mode that is, your calculator can lie to you, but if you type in cosine of 150, you should be getting a negative value. I forgot to write the negative here, but it's possible too, depending on the mode, you might have had that messed up. The x value, it's in the negative direction, isn't it? Double check yourself. Just because your calculator says positive or negative does not necessarily mean it is. Be smarter than your calculator. Okay, we need to do the same thing for the second force now. So with force number 2, it's the exact same setup. We're going to have cosine of the angle is going to equal x over the force, and sine of the angle equals y over the force that we were given in the original problem. Same thing, values are high, so you're going to multiply. So 103 cosine of 315, that's quadrant 4, so the x value should be a positive number when you type that in, and it is 72.83 newtons. And the y value here, when you multiply here, y is sine of 315 times 103, and that should give you a negative value when you plug in, and it does, negative 72.83 newtons. So all you're going to do now is you have a pair of y values and a pair of x values. So your resultant vector, and we're going to put it into that vector notation, is just going to be adding those two parts together. You get negative 114.23 newtons for the x component, and you get 35.17 newtons for your y component. So there is your resultant vector in the problem. As I try not to screw everything up here, bring those brackets closer together. So there's your resultant vector, a negative x value, a positive y value. That means quadrant 2, well, that's where we said this resultant vector should be. So that's good. Now, we want to get your answer into a form, though, that looks like this. How many specific newtons, and then at what angle? Well, that's just what we did in the previous video, where we need to find both a magnitude and a direction. So we're going to find a magnitude, and we're going to find a direction, just like in the last problem. The magnitude is really easy. Magnitude is just equal to the square root of x squared plus y squared. It's just Pythagorean theorem. And when you plug in your x and y values from down here, be careful, make sure you get that negative to turn positive when you square it. You plug in and you should get 119.52 newtons. To find direction, again, tangent of theta is going to be y divided by x. So when you plug those in, you'll get theta equals the inverse tan of those values, y divided by x, and again, they're coming here. Here's your y value, here's your x value. When you plug in, you're going to get in your calculator, when you plug in that value, you're going to get an answer of negative 17.11 degrees. Where is negative 17.11 degrees? Well, that would be down here in quadrant 4. Well, we knew our answer had to be in quadrant 2. So we need to figure out, well, 17.11 degrees, what's that going to be in quadrant 2? Well, it's, again, dealing with reference angles. So the way we get this 162.89 is we need to know that, hey, it's not quadrant 4, it's quadrant 2. So theta will equal 180 minus the 17.11, and you get the 162.89. Okay, that's the toughest part about this, is using that tail tip method and being smarter than the problem, knowing what direction we're going in. All right, at this point, I would like you to pause the video. We're going to take a look at Captain America and Iron Man. Yeah, we had a little Marvel movie night last night. And how they're going to be looking when they're in a battle. I want you to see if you can draw the force diagram and figure out, I even kind of mapped out exactly what you should be looking for. There's an extra component here. There's a force from Captain, there's a force from Iron Man, and there's also a force from gravity. Pause the video, see if you're able to come up with your values, and I'll even give you the answer, the final answer here, for you to check as you're going along. Okay, so here's what we're looking at with Captain and with Iron Man. So here's Loki, yay, give him the nice long hair, I guess. Captain hits a force of 4114 in the 80-degree direction, so there's Captain America's force. And Iron Man hits him with a much less force at 45 degrees. I should draw that, technically a lot less force. So based off those two forces right now, they're both going in quadrant 1, so the resultant force should obviously also be in quadrant 1. If you do tail tip, it's going to go big time in that direction. Your resultant vector should be somewhere up in there, somewhat much stronger. However, we also have the force of gravity that's pulling down on Loki as well at 400 newtons. So we need to figure out those x and y components. The gravity is the easy one. Gravity is straight up and down. There is no x component for gravity. There's only a y component, and it's 400 newtons in the downward direction. Make sure you keep in mind that that was a negative value. For Captain America, there's his x and y component. Again, based off the angle, they should both be positive because both x and y are positive there. Iron Man, if I can get it out of the way, there it is. Cosine value, sine value, again, they'll both end up being positive. So when you combine them together, you get your resultant. There's the y component of the resultant. There's the x component of the resultant, just like that. To find your magnitude, we do magnitude square root of x squared plus y squared. You plug those in, you get a little over 5,000 newtons. And again, we should expect that to be a lot harder and a lot bigger of force because they're both going in the same direction. Both forces being applied to Loki were in the same direction. As for direction, we should be in quadrant 1. And it should, in theory, be somewhere in between the 80 degrees and the 45 degrees, just based off of the diagram we've made. There's your resultant force, and the angle comes from doing tangent equals y divided by x. Do your inverse tangent, you get 68.29. We expected something in quadrant 1, and the value was in quadrant 1, so we know that that answer is correct. There you have it, your component vectors and turning them into finding resultants. Best of luck, and ask questions.